Dear students, we learn about linear equations. So we want to learn about linear inequalities. And unlike equations that have only one specific solution line, because of equal to sign x plus y equal to some value c, so that equation restrict us to give a one solution only. So inequalities describe region of solutions because of the signs less than, greater than, less than, equal to, greater than, equal to. So if we want to explain the linear inequalities by the definition, then the definition tells us that those expressions which includes negative less than or greater than, less than, equal to, or greater than, equal to signs are called inequalities. And if those expressions are linear, with less than, greater than sign, less than, equal to, greater than, equal to signs, then those those becomes linear inequalities. So solving rules for solving these linear inequalities: so addition, subtraction, when we add something, when we subtract some numbers, so sign will remain same. When we multiply with positive numbers, then sign will remain same. But the golden rule is you must flip the inequality sign when multiplying or dividing by negative number. So examples are so take an example. So linear expressions that contains negative, less than, greater than, or less than, equal to, or greater than, equal to signs are linear inequalities. Linear inequalities are two types. First one is of this type: 2x plus 1 without the sign of absolute value. So the second one is with absolute value sign. If you want to solve these inequalities and take off the absolute symbol, so 2x plus 1 will give greater than, equal to 2, and 2x minus 1 will less than, equal to 2. So we have to give two types of expressions more, because by the definition of absolute value of x is positive for all x is greater than, equal to 0, is negative for all x is less than 0. So this is the absolute value of the definite. By the definition, this is absolute value. So let's come to the main question of inequality. Now add negative 1 on both sides. From here we have added negative 1 on both sides. So 2x gives greater than, equal to 1, so x is greater than, equal to 1 upon 2. So if we want to plot this graph on a number line on a 2D plane, so this is 0, which is origin, 1 2 3, 1 2 3. Here x is greater than, equal to 1 upon 2. So by the greater than 1 upon 2 means half of this region. Here is the point. We will include this point because of this boundary will be included. All the other points will be included as well in this graph, because if x is greater than, equal to 1 upon 2. If x is greater than just 1 upon 2, we will exclude this point, and before and the remaining all the points will be included. So this we have already learned about the equation gives single answer, but the inequality gives regions of solutions. So this is the region of solutions, multiple solutions. So inequalities gives multiple solutions. We pick appropriate solution of the given question. So let's take an example of our golden rule. When we divide, then the sign will be flip. So first add negative 1 on both sides. So negative 2x is greater than, equals to 1, which is not true although, but when you divide with negative 2 on both sides, now take less than, equals to 2 here. So take less than 2, less than equal to 2 here. So less than equal to 2 negative 1, which is equals to 1. So dividing by negative 2, this sign will change. So here x is greater than equals to 1 upon 2. Okay, so we understood that when we divide negative numbers, then the sign will flip. Now the graphing of these linear equations, the graph of each inequality and their common regions of intersection of all the graphs. So this is just for one equation. If the equations have, let's suppose we add ax plus b is equals to y, sorry, b is equal to c, and a1 b1 equal to c1, a2x plus b2 is equals b2 b2y is equals to c2. Let's suppose we have these two system of linear equations. Let's suppose a1x plus b1y is equals to c1, a2x plus b2y is equals to c2. So these system of linear equations can be solved and plotted. Let's suppose this system 1, this is system 2, this is equation 1, this is inequality 1, this is inequality 2. If this inequality gives let's suppose we have not find any solution of these inequalities because these are general inequalities. So if we plot a graph of these inequalities, so it's less than equal to c1. So let's suppose this gives this graph. Okay, this is one equations graph, and if we plot for second inequality, let's suppose it gives this graph, then the common region is its common region is described by this with the help of this graph. Okay, the graph of each inequality and their common regions of intersection of all the graphs is called the solution region. Their common region is here. If this graph, let's suppose this graph shows upper region, and this graph shows also upper region towards origin. So this is a common region of this graph. Okay, the common region is also called a solution region of these two inequalities. A region which is restricted to the first quadrant. In this common region, a region which is restricted to the first quadrant. Let's suppose this is a common region as well. So it's in first quadrant. This is the second quadrant. This is third quadrant. This is fourth quadrant. In first quadrant, x and y are both positive. In second quadrant, value of x is negative, value of y is positive. This is negative. So in second quadrant, x is positive, y is negative. In third quadrant, x is negative and y is negative. And in fourth quadrant, x is positive, y is negative. So in this region that restricted to the first quadrant, that common region which is restricted to the first quadrant, you can say a region which is restricted to the first quadrant is referred to as a feasible region. So we need to have this feasible region for discussion, because in the linear programming we need feasible region for the discussion. Each point of feasible region is called feasible solution of the system of linear equations. So each point of the feasible, let's suppose this feasible region has this point, this point, this point. So this feasible region, each point of the feasible region is a solution of the system of linear inequalities. A set consisting of all the feasible solutions of the system of linear equations is called feasible solution set. This type of so the set of the set of all a set consisting of all the feasible solutions. uh, this set of points contains all the feasible solutions is a feasible solution set. So we have already told you that we are going to solve these equations by a graphing graphic method to solve system of linear inequalities inequalities. So the application of this system is linear programming. That is most important topic I want to tell you about. This topic that it has lost a lot of applications. This field has a lot of applications, like in risk management, like in for the business, whether the business is growing, whether the business will give maximum profit, for gaining profit, as well as in computer programming, as well as in agriculture. So a lot of applications have been discussing, and we want to discuss a specific scenario of, and we will solve the scenario and we will find the answer about with the help of these linear programmings and inequalities. So before the solution of these inequalities, we need to understand first three things. First of all, our objective function. First of all is our objective function, that is most important. Second one is subject to the constraints. That are constraints are basically limitations for what, whether to minimize our cost or something else. So let's suppose you want to sell a pen with $10, okay, and pen is $10 you already selling. You want to minimize, and your cost for producing is $6, and someone told you that I will give you material for this pen with $4. Okay, so our main we want to maximize our profit, so we will go with this $4 material. And the new thing that constraint includes is limitations. These limitations must be material must be good, material must be cost effective, and material will be provided continuously. These are our limitations. So without limitations we cannot solve these questions. So these are limitations, subject to limitations. First of all, our objective function. Objective is whether to maximize our profit or to minimize our cost. So this is our subject. This that will be mentioned in maximum or minimum way in a question, and the subject constraints are given in this way, and these are non-negative constraints. Non-negative constraints means the feasible region, means our solution region. That let's suppose we had a solution region always in our first quadrant, because x is greater than equal to 0, y is greater than 0. So we will get our solution region in always first quadrant. Now come to the question. The question is, a workshop makes tables, x tables, and y chairs. So profit is $40 per table and $50 per chair. We want to solve this question with the help of linear programming. So you just need to understand these three steps. That these steps are objective function, subject to the constraints, and non-negative constraints. A workshop makes table x, chairs y, and profit per table means to say tables x, $40 per table is profit, and $50 per chair profit. So our and this is our objective function. Okay, now assembly, for the assembly, 1 hour per table and 2 hour per chair, maximum 40 hours. We have to give 1 hour per table and 2 hours per chair for assembly of these tables and chairs. Means to say, to make these tables and chairs, we are restricted to give 1 hour per table and 2 hours per chair, when a maximum 40 hours per maximum we can give the chairs and table is 40 hours. Finishing, for finishing we can give 4 hours per table and 3 hours per chair, so maximum time we can give is 120 hours. So how many of each should be produced to maximize profit? Here the maximize the profit is given, so we need to maximize our profit. So in this way, let's take these values first. First of all, 50 tables. Let's tables are x and chairs are y, so 50 per table, so 50x, so 40x plus 50y. This is 40x plus 50y, which is subjective. Our our objective is 40x plus 50y, subject to the given constraints are x plus 2y is less than equal to 40, and constraints for other constraints are 4x plus 3y is less than equal to 20. These are all our constraints, these are all our limitations, that for 1 hour we can give for table, 2 hours for a chair, and 40 hour maximum we can give the table and chair to make. 4 hours for assembly of the tables, 3 hours for the assembly of the chairs, so maximum we can give is 120. So these are our limits, these are greater than equal to 0. These other constraints that are always positive constraints, here non-negative constraints. These give the feasible solution to the first quadrant. Now take x plus 2y, x plus 2y is less than 40, so our corresponding equation is x plus 2y equal to. Why we use this equal sign here? Because we are restricted to less than equal to 40, so our equations become x plus 2y equals to 40. So we can solve for less than as well, but we need to have maximum value for this solution. So in this corresponding equation, put 0 as x. This will here 0 plus 2y is equals to 40, so y becomes 40 upon 2, which is equals to 20. So our y value becomes 20. So when we put 0 as a y, so x plus 0 is equals to 40, so 2 into 0 is equal to 40, so x becomes 40. So we had these 2 points for this constraint. Now put x equal to 0 and in this corresponding equation, so for 4 into 0 plus 3 into y is equals to 120. So this becomes 3y is equals to 120, y is equals to 40. So 0 and 40 we have this we had a point. So if you put 0 and y, 4x plus 3 into 0 is equals to 120. So now put 0 3 into 0 plus 4x is equals to 120. So 4x is equals to 120, so x becomes 120 upon 4, which is equals to 30. So we had these points. First of all, for x and y we have 0 and 20 point, and 40 and 0 point. Here we got 0 and 40 and 30 and 0 point. We got these points. Now we want to plot these points. our points are, for one value, for one equation, these are points 0, 20, 40, 0. So 0, 20, 40, 0. Here is 0, 20, and here is 40 and 0. So in the next 0, 40, 0, when x is 0, value of y is 40. When x is 30, so this is, I think, wrong. So when x is 30, value of y is 0. So we can here remove this, we can remove it. Okay, so this is a 20, this is 30, so we can add here. So okay, this is 30 and 0 point. Now we have to find the corner points, because this region is meeting at a point here. We want to find corner points. So in this way, the equations are x plus 2y is equal to 40, and 4x plus 3y is equal to 120. If we multiply the above equation by 4, then this equation becomes 4x plus 8y is equals to 160, because 4 when multiplied by 40 becomes 160. So 4x plus 8y is equal to 160. Here is always already 4x plus 3y equal to 120. So this negative, when we subtract these two equations, 4x will be cancelled out, and 5y is equal to 40, so y is equals to 8. And now put this value in any of the equation. So we put this equation, this value of y in second equation here. So 4x plus 3 into 8 is equal to 120, 4x plus 24 is equal to 120, 4x is equals to 120 minus 24, 4x is equal to 96. So x becomes 24. So 24 and 8 is the point of intersection. So we had all these points. Now draw all these points. Points are 0 and 20, 40 and 0, 40 and 0, 0, 40, 0, 40, 30 and 0, and the common point is 24 and 8, 24 and 8. Constraint, we will write the constraints here. X plus 2y is less than equal to 40, x 4x plus 3y is less than equal to 120. Now keep in mind that to get a feasible solution, this point must satisfy both the inequalities. Just keep in mind this thing. This point must satisfy all this inequality along with this inequality. If one inequality is not satisfied, one is satisfied, then solution will this point will not be considered. Okay, both for consideration, this point must hold all these inequalities to satisfy. Okay, so let's put 0 here. So if you put 0 here and 20, so 40 is less than equal to 40, so it's true. if we put here 0, so x becomes 0 plus 20 multiplied by 3 is equal to 60, which is less than equal to 120. So this is true, this is true, so we will use this point. So 40 and 0, if we put x equal to 40 and 2 into 0, which is less than equal to 40, this is true. But when we put 44 into 40 plus 3 into 0 less than equal to 120, so this becomes 160 is less than equal to 120, which is wrong, so we will not use this point. So 0 and 40, if we put x, value of x is equal to 0, value of x is equal to 0, and the value of y equal to 2 into 40 is less than equal to 40. So 2 40s are 80 is less than equal to 40, so which is wrong, so we will not use this point. This point will not be used. So 30 into 0, put x equal to 30 plus 0 2 into 0 is less than equal to 40, so this becomes 30 is less than equal to 40, which is true. And put here 4 into 30 plus 3 into 0 is less than equal to 120, so 120 is less than equal to 120, which is true, so we will add this point. So when put 24 plus 2 into 8 is less than equal to 40, so 24 plus, so 40 is less than equal to 40, this is true, so put 4 into 24 plus 3 into 8 is less than equal to 120, so 120 is less than equal to 120, this is also true, so this point is also included. Now our main goal is to find the maximum solution. Our objective function is was p of x and y is equals to 40x plus 50y, and points that we use here is 24 and 8, 0 and 20, 30 and 0. These points, put these point one by one in the objective function. So 40 into 24 plus 50 into 8, which gives $1,360. 0, 40 into 0 plus 50 into 20, which is equals to $1,000. 40 into 30 plus 50 into 0 is equals to $1,200. So here this point gives the maximum profit, so 24 and 8 gives maximum profit, so our question was to maximize the profit. Okay, here 13 and this point 24 and 8 gives the maximum profit, that produce 24 tables and 8 chairs for each for the optimal results. So for the optimal results, you need we need to produce 24 tables and 8 chairs for the optimal results. Thank you.